Efrosini Kokalari, and I am professor in the chemistry department of the University of Tirana. Thank you for giving us the opportunity to participate in the conference, wishing all of you success. Recently, more and more priority is given to green chemistry in many fields of applied sciences. The use of green inhibitors for the protection of metals and their alloys from corrosion is very important because they are not toxic to the environment or to living creatures on it and have a low production cost. Our work group has many years of experience in the extraction of this kind of inhibitors from plant materials as roots, leaves or fruits. The purpose of this paper is to present our experience in the preparation of alcoholic extracts from plant material such as walnut fruit septum, ulmus leaves and arundodonax leaves. All of them are mostly found in Albania. The extracts were then analyzed by spectral methods, IR spectroscopy, UV-Vis and HPLC. From the data obtained from the spectral analysis, the presence in the alcoholic extract of chemical structures containing heteroatoms such as oxygen, nitrogen, p electrons, phenolic rings was verified. This is the reason that the prepared inhibitors have good protective properties against the corrosion. As you can see, the IR spectra of the solid alcoholic extract of walnut fruit septum displays strong and broad band that is attributed to oxygen-hydrogen stretching. There are bands that related to carbon-hydrogen stretching vibration and peak that is attributed to the carbonyl group stretching. Also, there are strong bands that could be assigned as aromatic rings. UV-Vis spectrum of walnut fruit spectrum extract shows two peaks at 201 and 276 nanometer, which belong to lignin and condensate tannins respectively. Lignin is a complex class of organic polymers, in the composition of which there are phenolic rings connected to various organic functional groups with a large presence of hydroxyl and oxygen groups. Even in condensate tannins, there are presence of phenolic rings, hydroxyl and oxygen groups. HPLC chromatogram for alcoholic extract of walnut fruit septum show the presence of gallic acid and catechin as we expect. The IR spectra of ulmus leaves alcoholic extract show the presence of chemical compounds as catechin, isoquercitrin, quercetin. There is band that is related to carbon-hydrogen stretching vibration and peaks that are attributed to the carbonyl group stretching. There is also a strong band that could be assigned as aromatic rings. HPLC analysis of ulmus leaves extract show the presence of chemical compounds, especially catechin and quercetin, as we expected. Now, the IR spectra of arundodonax leaves alcoholic extract show the presence of chemical compounds as alkaloids, especially donaxarin and sterols. There are peaks that show the presence of lignin, hemicellulose, cellulose and polysaccharide. HPLC analysis of arundodonax leaves extract show the presence of chemical compounds, especially alkaloids, phenols, xanthan and xanthone, as we expected. We can conclude that the alcoholic extract of plant materials that have been analyzed, walnut fruit septum, ulmus leaves and arundodonax leaves, can easily prepare and with low cost. The alcoholic extracts of these plant materials contain chemical structure as polyphenols, glucosidic compounds, tannins, alkaloids with heteroatoms as oxygen, nitrogen, p electrons, and phenolic rings. These extracts were tested as green inhibitors against the corrosion for iron B500B with very good results.